Hello guys, welcome in today's session. I am Professor Fayaz Khawadi from Department of Mechanical Engineering. In today's session, we are going to learn how to draw the cam profile for oscillating a roller follower, which is our last part and part number 5 from unit number 4 cam and follower from theory of machine subject. The problem statement for understanding how to draw the cam profile for oscillating follower. The problem statement is in front of you. The following data related to a cam operating a roller oscillating follower. Minimum radius of cam is given 30 mm. A roller radius is given 10 mm. Length of follower arm 45 mm. Distance of fulcrum center from cam center 55 mm. Angle of ascent 80 degree. Angle of descent 120 degree. Angle of dwell at maximum lift is given 50 degree. And last, angle of oscillation of follower is given 28 degree. We have to draw the cam profile for given data. First of all, before starting the actual problem, we have to clearly understand that what is the difference between a reciprocating and oscillating follower. As figure is in front of you, in a reciprocating follower, the follower is moving in a predetermined straight path. But in case of oscillating follower, the follower is moving on predetermined circular path. It is the arc of circle. It is part of circle like pendulum of wall clock or wiper of automobile. So this is fixed at one fixed point, which is called as a fulcrum point, and it is oscillating on a predetermined circular path. So this is the difference between oscillating follower and a reciprocating follower. Next, first step for drawing the cam profile is to draw the displacement diagram. For drawing the displacement diagram, first we have to calculate the displacement of follower, which is not given in problem statement. As you can see, the data is in front of you. The displacement of the follower that we have to plot on y-axis is not given. Okay, but angle of oscillation of follower is given 28 degree. S is given in terms of degree, and that is angle of oscillation is given, that is given 28 degree. Okay, that 28 degree we have to convert in displacement of the follower in mm. Okay, so in front of you the oscillating follower, you can see in the figure the length of the oscillating follower is given 45 mm in the data, and angle of oscillation is given 28 degree. Angle of oscillation is given 28 degree. So we have to find out the displacement, which is the distance O dash. S is nothing but O dash. So that S will be directly given in the problem statement in the examination, or that S is given in terms of angle of oscillation. That angle of oscillation you have to convert into linear displacement, that is S. Okay, so how will you convert that angle of oscillation in S displacement? See, in mechanics you have already learned this is part of circle, arc of circle. This is S, that we have to find out this S. This length of arm is given 45 mm and degree of oscillation is given 28 degrees. So this will become theta, and this will become a radius of the circle. So we can find out this S, as we know the formula which we learn in mechanics. So S is equal to R into theta. S is equal to R into theta. So that S we have to find out. So this will become R, radius of circle, which is 45 mm, and this is theta is given 28 degree. So putting the value of r and theta, 45 mm r, and theta is given in degree 28 mm, which I will convert in radian by multiplying pi by 180. Okay, so after calculation, the value of S I'm getting here 21.991 mm. So after rounding off this value, I'm getting S as 22 mm. 22 mm. Okay, 22 mm. Now the question arises here, why the motion of the follower is not given in the data? The data is in front of you. I show you the complete data from the problem statement. In this data, again one follow motion is missing. No, that motion is not missing. Whether the follower is moving with uniform velocity, whether the following is moving with simple harmonic motion, whether it is moving with cycloidal motion or uniform acceleration and retardation, that data is not given. That means that is not missing. Remember, in case of oscillating follower, when the follower is moving or moving or having oscillatory motion, it is directly having simple harmonic motion. Okay, because when the follower is oscillating at that time, it has only simple harmonic motion during ascent and descent. That point you have to clearly remember for solving the problem in the examination. So that data is not missing. When the follower is moving with oscillatory motion, at that time it have only simple harmonic motion during ascent and descent, like pendulum of wall clock. Okay, now this 22 mm which I found out, that 22 mm I will directly take on vertical axis on y axis 22 mm, and as per regular procedure on x axis I will plot cam angle, rotation of cam angle theta, angle of outward stroke is given 80 degree, angle of dwell is given 50 degree, and angle for return stroke is given 120 degree, and I will draw the displacement diagram for simple harmonic motion of oscillating follower. And the procedure how to get the intersection point A, B, C, D, E, F, and in return stroke G, H, I, J, K, L, M. You know the complete procedure, and I will share the link of this video also. How to draw the displacement diagram. Okay, now after drawing the displacement diagram, come to the actual problem statement that we have to draw the cam profile. So first step is draw the base circle of radius 30 mm. Draw the base circle with center O1 of radius 30 mm. So in compass, I will take 30 mm distance and I will draw the complete circle, which is a base circle. Now a radius of a roller is given. A radius of a roller is given, and I assume that the exact position of the roller is above the center O1. So I will take the radius of a roller, which is given 10 mm. In the data, a roller radius is given. A roller radius is given 10 mm. That 10 mm I will take in the compass, and I will draw the circle, which is nothing but a roller. Okay, and this O point is nothing but pivot point in case of a roller follower, and then O1 as a center and O1O as a radius. I will draw another concentric circle, which is nothing but prime circle. Radius will become 40 mm here, but that radius of prime circle is not directly given in problem statement, but radius of a roller is given. So 30 mm radius of base circle plus 10 mm radius of a roller, which is 30 plus 10, it will become 40. So in the compass, 40 mm as a radius and O1 as a center, I will draw second concentric circle, which is Wine circle. Okay. Now it is assumed that initially roller is above the center O1. This is assumption. And why? Because it is not directly given in problem statement whether what is the first position of roller. Now the second point, mark the pivot point O2. Mark the pivot point O2. That point I have to mark. What is the, how to mark that O2 point? See, length of the follower arm is given 45 mm. 45 mm. So here 45 mm is given length of the follower arm. This 45 mm I will take in the compass. Okay, and O as a center, I will draw the arc here. 45 in the compass, O as a center, I will draw the arc. Okay. Now second step, then O1 as a center, O1 as a center, and 55 mm distance in the compass. 55 mm. Why 55 mm? Because in the problem statement it is given 55 mm. Distance of fulcrum center from cam center is given 55 mm. Distance of fulcrum center from cam center is given 55 mm. So that distance, that is the fulcrum center, and this is the cam rotation center. That distance is given 55 mm. So 55 mm in the compass, O1 as a center, I will draw the arc which will cut the previous arc at point O2. So that point I will get here, O2 point, which is the intersection of O2O and O1O2. That is the intersection point. This is nothing but a fulcrum point on which that arm is oscillating along with a roller. Okay. And why should I draw O2 point left side of that vertical axis, not right side? You can draw the right side also, as it is not given in problem statement. So I draw left side. You can draw right side also. Okay. Right side also. So I mark point O2. Understand how to mark the point O2? O1, O2, distance in the compass which is given 45 mm, length of arc. O1 as a center, I will draw the arc. Then O1 as a center, and O1 and 55 length in the compass. I will cut the previous arm where I got the intersection point. That intersection point will be O2. In this way, I will plot the fulcrum point. Okay. Now come to the next step. Second step, draw the pivot circle. Pivot circle. See, in oscillating follower, you have to draw 3 concentric circle. First circle is base circle. Second circle is prime circle. And third extra circle in oscillating follower, that is a pivot circle, which is concentric with previous 2 circles. So O1 as a center and O1, O2, this is a fulcrum point. Okay, fulcrum point. So O1, O2 as a radius in the compass, I will draw third concentric circle, which is a pivot circle. Okay, this is the second step. Next, third step, mark the outward, dwell and return angle in anti-clockwise direction. My assumption is the follower is moving clockwise direction, so my procedure will start in anti-clockwise direction. So procedure of plotting the outward angle, dwell angle and return angle will start in anti-clockwise direction from line O1, O2, from line O1, O2, this line O1, O2. You have to measure, you have to start measuring angle from this line, not from vertical line. Don't make mistake in examination also. You have to measure the outward angle from line O1, O2, this inclined line, which is a center line of joining O1 and O2. From this line, you have to measure outward angle, which is given 80 degree, dwell angle, which is given 50 degree, and third, a return angle, which is given 120 degree. Clearly understand that point. You have to measure outward angle, dwell angle, and return angle with respect to line O1, O2. Okay. And next step, divide that outward stroke and return stroke into 6 number of equal parts as you divide in displacement diagram. You divide in displacement diagram outward stroke into 6 number of equal parts and return stroke into again 6 number of equal parts. Okay, so you have to divide here also outward stroke 80 degree into 6 number of equal parts and here 120 degree into 6 number of equal parts. And mark the point 1, 2, 3, 4, 5, 6 on pivot circle, not on prime circle. That is the difference. Okay, mark that point 1, 2, 3, 4, 5, 6, 6, 7, 8, 9, 10, 11, 12 on outermost circle, that is a pivot circle. Okay, pivot circle. Now come to the next point. Now considering point 1, 2, 1, 2, 3, 4 form, these are the centers. These are the center and length of the follower arm as a radius. O2 you have to take in the compass, which is 45 mm, which is 45 mm, which is length of the follower arm. Why that distance you have to take 45 mm in the compass? Because that is the fixed parameter which is not changing. Length of follower is not changing for every position of a roller. Length is not changing. That is the fixed parameter. Position of roller is goes on changing, but length of follower, which is a fixed parameter, length of the link O2O is not changing for every position of follower. So this is the fixed distance. That fixed distance I will take in the compass O2. Okay, and 1 as a center, I will cut the prime circle at point 1 dash. Clearly understand the procedure. Length of follower O2O, which is 45 mm, that much distance I will take in the compass. 1 as a center, I will draw the arc which will cut the prime circle at point 1 dash. Now 2 as a center, the same distance in the compass, that distance is not changing. So don't change the distance in the compass throughout the procedure. Okay, 2 as a center, 45 mm in the compass, cut the prime circle at point 2 dash and draw the arc. Then 3 as a center, 45 mm distance in the compass, draw the arc where it cut the prime circle, give the number to that intersection point as 3 dash. Then 4 as a center, the same distance in the compass, that is 45 mm, cut the prime circle at point 4 dash and draw the arc. Then 5 as a center, 45 mm in the compass, which is not changing for every position, 45 in the compass, 5 as a center, draw the arc which will cut the prime circle at point 5 dash. In this way, you will got the different points as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash. Likewise, same 6 as a center, the 45 distance in the compass, cut the arm, cut the point circle and draw the arc where it cut the point circle, give the number as 6 dash. Likewise, you will get here 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, 12 dash. Okay, that all the point will be on point circle, and this 1, 2, 3, 4 point will be on pivoted circle. Okay, pivoted circle. In this way, you will get the 1 dash, 2 dash, 3 dash. Now the next step is then from the displacement diagram, take the distance 1a from the displacement diagram. Now come to the displacement diagram. 1a, that distance 1a, 2b, 3c, 4d, 5e. In this way, first you have to take 1a in the compass, 1a in the compass, take the and 1 dash as a center, cut that arm, cut that curvature at point A. Then 2b, that much distance from the displacement diagram, cut the second arm, where it cut the arm, cut the second curve, where it cut that curve, that point will be B. Then 3c from the displacement diagram and 3 dash as a center, cut the third curvature at point C. 4d from the displacement diagram and 4 dash as a center, cut the fourth curvature at point D. In this way, you have to cut all the curvature from taking the distance from the displacement diagram 1a, 2b, 3c, 4d, 5e, 6f. In this way, 6g, 7h, 8I from the displacement diagram, 9J, 10K, 11L and 12M. From the displacement diagram, you have to cut that respective curvature and give the numbers like G, H, I, J, K, L, M. Okay. Now, whatever points you are getting here, A, B, these are not the point of tangency through which you have to draw the curvature. These are the centers of a roller. Understand that point. These A, B, C, D, these are the centers of roller. So A as a center, draw the roller position. B as a center, draw the roller, which is 10 mm radius. In this way, A as a center, this is the first roller position. Then A as a center, draw the arc. B as a center, draw the roller. What is the radius of roller? That is 10 mm. So B as a center and 10 mm in the compass, draw the roller position. C as a center, draw the roller position. D as a center, draw the fourth roller position. E as a center, draw the next roller position. So while drawing the roller, the distance radius of the roller is not goes on changing for every position. So that distance will fix in the compass. That is not goes on changing for every position. So that will be fixed constant distance that you won't change in the compass. Only you will goes on changing the centers of the roller position. Then F as a center, draw the next roller position. Then G as a center, draw the next roller position. Then H as a center, draw the next roller position. I as a center of a roller, draw the next position of a roller, which is 10 mm. Then J as a center, 10 mm distance in the compass, draw the circle here. Then K as a center, draw and 10 mm distance in the compass, draw the roller position. roller. Then L as a center, 10 mm in the compass, draw the roller, okay, and 12 or M as a center and 10 mm roller diameter, a roller radius, draw the next roller position. And after that, you have to draw the curve which is tangent to the roller surface. Tangent to the roller surface. Here you can see clearly the cam profile. You have to draw the cam profile which is tangent to the roller surface. You have to draw the cam profile which is tangent to the roller surface, not from point A, B, C, D. If you draw the curvature from point A, B, C, D, your cam profile will be wrong and you will get 0 marks in the examination. Okay, so you have to draw the arc which is tangent to all the rollers position, and you have to draw the cam profile. You have to complete the cam profile. The final view you can see in this image as cam profile while the follower is oscillating a roller follower. Okay, oscillating a roller follower. So clearly understand the procedure how to draw the cam profile for oscillating a roller follower. Okay, so at the end of this session, the student can understood the procedure of drawing cam profile for oscillating a roller follower. Thank you for watching this video.